This is RD Sharma solution, class 12, chapter 3, binary operation, exercise is 3.1. Now the next question is saying, this is question number 2, determine whether or not each of the definition of star, that is the operation, given below gives a binary operation. In the event that star is not a binary operation, give justification on this. So the first part we have already done. The question number 1, we have around 7 parts. This is almost similar to it, and this is a NCERT question. So one by one we'll take. The first one is on Z plus, defined star by A star B equals A minus B. Okay. So this A star B is defined as A minus B. Now in binary operation, if you have a set, for example, the set is Z plus here, which is actually the positive integers. So if you take A from Z plus, B from Z plus, the A minus B should also belong to Z plus. Then it will be binary operation. Otherwise, it will not be a binary operation. Right? Okay. So let me tell you Z plus again. Z plus are all the positive integers. That is, if you take Z minus, that will be negative integers. And Z is all positive and negative integers. So 0, 1, 2, 3, like this, it goes up to infinity. This is Z plus. Okay, Z plus is the set of non-negative integers. Okay. Now, as I said, A and B has to be taken from this set only. So if you take A as 1, and B as 2. So A cross B is what? This is equal to A minus B. So A is 1, B is 2, there is negative 1. Now you see this negative 1 is not belonging to this Z plus. It is not there even in the set. So it is not a binary operation. Star is not a binary operation on Z plus. Then we have the second part. On Z plus, define star by A star B equals A into B, A multiplied by B. So A star B is actually equal to A into B. So it is on Z plus. Z plus is, again, let me write it. The multiple question on Z plus. So this is non-negative integers. So what we will do? We'll take two values from here, from the Z plus, and we will multiply them. When we multiply them, it will belong to that set only. You take any two values, any value of your choice, multiply them A into B, and you'll see that it will always be positive. So it will always be in Z plus, positive integer. Since there is no rational number, no real number kind of thing, so this all means decimal kind of thing. You don't get any other value. You'll always get a value belonging to this set. For example, if you take A as, say, 2, B as 1, this is A into B, 2 into 1, which is 2, belonging to this set only. So if you even multiply by 0, 0 is also there. So the star is a binary operation on Z plus. Third part is on R, defined by A star B equals AB square. This real number is the biggest set. Let me tell you, it is the highest set. All other set, mostly they belong to this set. So this A cross B is defined as AB square. So the natural number, all the other integers, all they belong to this real number only category. So everything is possible here. So if you take A from the real number set, B from the real number set, and if you multiply B twice and A single time, that is AB square, it will always be in the real number only. As I said, real number is a bigger set. All other set which we have discussed up till now, they are inside the real number. So they will, any number you take, they will be in this bigger set. So this star is a binary operation on R, real number. Next one, we have fourth one. On Z plus, define star by This z plus, let me write it again, 0, 1, 2, 3, 4, 5, like this. Okay, z plus is all positive integers. This is defined by a star b equals mod of a minus b. Now, this already we have taken the first part, right? So what we said, when we take the value a star b, it was not a binary integer. But here we have a modulus. Modulus will always give you a positive number. So these are all positive values. Even if you take any bigger value and smaller value, or you subtract this smaller value, or you can say a higher value from a lower value, you'll get a negative value. For example, 2 minus 1 and 1 minus 2. They both are 1 and negative 1. But still, since we have this modulus, it will always give you a 1. Okay, so this star is a binary operation on z plus. Now fifth one, on z plus, define star by a star b equals a. Now this is very easy. If a star b is a or a star b is b, the basic binary operation definition is if a belong to this set, b belong to this set, then the a operation b result should also belong to this set. Since a is already belonging to this set, a is already there. This is a binary operation on z plus. Now the sixth one, on R, define star by a star b equals a plus 4b square. Now you remember this third part which we just saw? The definition is similar to that. Okay, so you don't have to worry about anything. If you insist on putting values from real set and a some value you take, b also you take, say 1 or 2, you don't have to worry about that because it is a real number set. It is the bigger set. All other, you can call it as a father of the sets. So whatever you give in place of a and b, you will always land up that the value which is inside the real number. So this star is a binary operation on R in this case. I hope you got the idea. Because R will maximum binary operation you'll see whenever you get a set R, you'll get a star as a binary operation on these real numbers. Now question number 3. The important thing is that this has already come in CBSE 2011. Okay, so it can come in 1 or 2 marks. Let star be a binary operation on the set I of integers. Normally we write z, but here they are giving it as I. Defined by a star b equals to 2a plus b minus 3. Find the value of 3 cross 4. So you don't have to worry about this I or Z or etc. because their expression is already given. You just have to find out a star b. A is given as 3, b is given as 4. So 3 star 4 is what? See, replace a by 3, replace b by 4. So 2 into 3 plus 4 minus 3. This is 3 to the 6. And you have 4 minus 3. So 10 minus 3 is 7. Okay. Coming to question number 4, so it is given as, is star defined on the set? This star is an operation defined on the set. Set is already given. Let me just show you here in the first row and first column. This is already a set which we are defining. 1, 2, 3, 4, 5. This is also a set. First row, first column of binary operation table is always the set. And this is defined by a cross b equals the LCM of a and b. So LCM of b, a and b. So we have to show, is this star defined on this set is a binary operation or not. Okay. LCM is lowest common multiple. That is the value which is divisible by all the values which are the ingredient. or they are making the LCM. So I'm just showing you here, I'm not making the table. I'll take two value. The same set you have to write in the column and the row. The first A you have to take from the first column, the B has to be taken from the first row. For example, 1 and 1. 1 and 1, what is the LCM? 1. So let us take a proper example here, and then you'll see what values will come, how the value are coming. So all these are basically the multiplication, but not. LCM is not always the multiplication. Mainly here it is shown as the multiplication. Let us take A as 2 and B as 3. Okay. So 2 cross 3. A is 2, B is 3. What is the LCM of AB? 2 into 3. That is 6. Okay. So 6 is there or not? 6 is there, but it is not in the set. Neither 6 nor 12, 15, 20. All the numbers which are here, mostly they are not belonging to the set S, which is already being defined 1, 2, 3, 4, 5. So this is against the definition of the binary operation. Okay. Binary operation means if you have A belonging to this set, B also you are taking from the same set, the A cross B should belong to that set. Question number 5. Let S equals ABC. Now you don't have to worry about what is inside this set. You just have to worry about numbers here. Because the question is find the total number of binary operations on S. Okay. The previous question which I just did and explained, this is a NCERT question, and the good thing is the NCERT people can understand this also and extra question also. So coming to question number 5, before going to actual result, now I have to tell you, because I've already explained this in the theory part. But let me tell you again how this number of binary operation on a set with n element is n to the power n square. How does it come? So let us go to the set theory first, and then we'll try to understand. This is set A, this is set B. So we are trying to find out number of relation or the number of combination. Let us say A has n values, B has m values. For example, A has 1, 2, B has 3, 4, 5, whatever, whichever number you take. But I'm saying that A has n values and B has m values. So A will correspond to actually the domain and B will correspond to codomain. So A is having n value, B is having m value, A is a domain and B is a codomain. So the number of operations possible is codomain to the power domain. That is m to the power n. Same thing we are going to do here. How do we define a binary operation? Star is defined as A cross A. And this arrow is for A. That is, A is taken from this capital set A, B is taken from capital set A. When we operate A and B, the result should also go to that particular A from which the A and B has been taken. So this C also should belong to this set A which we have defined. Let us say this A has n values. So this n cross n will be n square. Here we have, that is the domain has n square. And then we have this codomain, it has n value. And then as I said, codomain to the power domain, that is the codomain is n and the domain is n square. That is how n to the power n square has come. Okay. Now let us come to the question and answer it. The set has A, B, C. Don't worry about the numbers or the values here. Just count them. So there are 3 values here. So what is the formula? N to the power n square. 3 to the power 3 square. That is going to be 3 to the power 9. So you can compute it 3 to the power 9 and you can keep it like that also. That is also okay. The question number 6 is exactly same as the previous one. Find the total number of binary operation on A, comma B. So you have A, comma B. As I said, don't worry about this. Just worry about how many elements are there. So S is equal to A, comma B. Now we have A and B, right? So how many elements are there? 2. And we know the formula, n to the power n square. So n to the power n square. So n is 2 here. So 2 to the power 2 square. So this is 4. 2 to the power 4. That is going to be 16. Okay. Question number 7. Prove that the operation star on the set. Now the set is given like this. M is given as, now you can call it as a determinant, you can call it as a matrix. So it doesn't matter because we have to do the matrix multiplication ultimately. So it is defined by A0, 0B. These are the matrix element, and we have A and B. This is belonging to R. So real number. A and B should be real number. It should not be 0. So R minus 0 is that it is a real number. A and B should be taken from real number, but you cannot take a 0. It is defined as A cross B or A star B equals A into B. So you have to do a matrix multiplication here. So is a binary operation. Prove that. Okay, let us take A and then B, and then we do the operation. So you have to multiply it basically. Okay. So we will take A and B and then we'll multiply it. So let us take A and B and just give the elements as A1, B1 and A2, B2. Or you can take any other value. It's up to you. I'll be giving you a very naive kind of solution of this. See, A into B. So let us take A. A has to be taken from this set only, right? M set. This is A0, 0B. I'm taking A1, 0, 0, B1. Then you have the B. So you are multiplying it basically. What is B here? See, B is A2, 0, 0, B2. Now the row has to be, first row has to be multiplied by both the columns. So A1 into A2 plus 0 into 0. Then we have first row with second column. So A1 into 0 plus 0 into B2. Then we have the second row with the first column. So second row with the first column. So 0 into A2, that is 0 into A2 plus B1 into 0. Then we have the second row with the second column. 0 into 0, 0 into 0, and then B1 into B2, and then just add it. Okay. So what do you get ultimately? You get, this is 0, this is also 0, so you get A1, A2, 0. So A1, A2 you get, here you get 0, here you get B1, B2, and then we have this also 0. So what do you get here? You remember A1 and A2 we are taking from real number, no zeros here, because R minus 0 means you cannot take 0. So if A1 is belonging to real number, A2 is also belonging to real number. So A1 multiplied by A2 will always belong to a real number, since A1, A2 cannot be 0. Okay. Even if it is 0, it doesn't matter because it will belong to real number. Real number has 0 inside it. Okay. B1, B2, the same logic goes. B1 and B2 belonging to real number. So B1 into B2 multiplied by B2 will always be real number. Right? Okay. So this particular result is also belonging to this M set. This M set. This star is a binary operation on this capital M. Because A is belonging to M, B is belonging to M. Question number 8. Let S be the set of all rational numbers of the form M by N. So this set is of the form M by N. Please remember, the set is a kind of rational description here, M by N, where M and N are clearly specified. M can only be an integer, okay, and the N can only be 1, 2 or 3, nothing else. So M, Z, N, 1, 2, 3. So what you have to prove is, or what you have to show is, prove that star on S, that is the operation on S, defined by A star B equals AB, AB is nothing but A into B multiplied by B, is not a binary operation. Okay. So let us take certain example here. M should always be Z, or coming from Z. Z is what? These are all negative and positive, 1, 2, 3 till infinity. Negative 1, negative 2, 1, 2, and this goes up to infinity on both the side, either side. Okay. So what do? Let us take A and B as an example. So A, let us take one value from M. You can take any value of your choice. I'm taking 1. N has to be taken only from 1 to 3. So let us take 3. B also m by n. M can be taken any value. So take just 5. But n can only be taken as 1, 2, 3. So let us take the highest value, which we have taken in A also. So 3. I am taking 3 highest value. Now multiply A and B. That is A star B is defined as A into B. So just multiply it. 1 by 3 into 5 by 3, what do you get? You get 5 by 9. And this 5 by 9 should be of the form m by n. A we have taken from m by n, that is S. B is also m by n, that is S. The result should also come from m by n. M should be an integer, n should be what? Coming from 1 to 3. But 9 is not from 1 to 3. 9 is not in 1 to 3. So this is not a binary operation. So question number 9. This is a CBSE 2012. It has already come there, okay? So this is a very basic exercise of this chapter. So the binary operation is star such that real number to real number, that is r cross r is through real number, is defined as a star b equals to a plus b. So we have to find out 2 operation 3 operation 4. Okay. Now, so what you have to do is first you have to use 2 and 3 as a and b. The 2. First take a as 2 and b as 3. And then whatever the value is there, just put it in the place of 2 star 3 and then operate it for 4. So 2 into 2 plus 3, I have taken a as 2, b as 3. So what you get to do is a 4, 4 plus 3 is 7. So 7 star 4 you have to do. Okay. That is, you have to reapply 2a plus b again. So save 7 operation 4. Now in the place of a you are going to take 7. And in the place of b you are going to take 4. So 2 into 7 plus 4 is 7 is 14. 14 plus 4 is 18. This is your final answer. Now people say, why do you show the answer? You are just copying it. And my logic is I am trying to make you understand what exactly how the solution goes. See, if you want to write in your copy, then you have to write like this. But need to understand the logic which I am suggesting you here. Okay, question number 10. Let star be the binary operation on n given by a star b equals LCM a comma b for all a comma b belonging to n. We have to find 5 cross 7 or 5 star 7. That's a very straightforward question. It has come in CBSE 2012. So 5 star 7 you have to find out. And 5 star 7, that is LCM of 5 and 7. What is the LCM of 5 and 7? They don't have anything common. So 5 7 is 35. 35 is the answer. Okay. The LCM is that value which can be divided by both the values which are the value which have found out this LCM. Okay. Lowest common multiple, 35 is the answer. Okay, this is all about this exercise. Thank you so much. Take care of yourself.